I'm Vincent Scheib. I'm a software engineer on Chrome, and I want to talk to you about connecting the web with the physical world. Now, we've already been doing a little bit of work in this direction, so let me take you back. We talked at a previous Chrome Dev Summit about Web MIDI, and I'm excited to tell you that earlier this year in May, we launched Chrome shipping Web MIDI support for people to use in their real-world apps, and mainstream major companies have adopted it and are relying on it now for their new devices, including PV and Yamaha. And what are they doing? They're doing a simple thing. They're connecting the web, which has traditionally been on that one device that you're using the web, to other devices outside your initial device. And that's a big deal. And we're continuing to go down that route. How can we make the web more powerful? How can we make connecting computing devices more powerful and easy using the benefits of the web? And to do that, we're connecting the web to other things in multiple ways. I want to talk to you about a little story. I'm a dad. Earlier this summer, I took my kids to a theme park. We had a great time, and at night they had a show. And if you have kids, you know that you have to keep them entertained all the time. They're always needing something. So waiting for the show, even 10, 20 minutes, is a long time to wait with kids. Well, the show was at night, and there's this big Ferris wheel. And the Ferris wheel's all lit up. Some people noticed my censoring of the slide. Ferris wheel's all lit up, and they tell me, there's a game to play. And I'm like, great, my kids are gonna love a game. You can play on your phone. Okay, I have a phone. I have two. My wife is here too. It's gonna be good. And I'm thinking, oh no, I'm the IT guy as well. That means I'm gonna have to install an app. It's gonna ask for too many permissions. I'm gonna have to uninstall these later. It's just to fill 15 minutes, you know. And then they tell me, oh no, it's gonna work on the web. And I thought, that's a perfect match. Here I am, it's a short-lived experience, and the web can do everything I need. And it was a memory game, kind of like Simon says, the Ferris wheel lights up, you play along on your web device, and the cool thing is, whoever in the crowd wins gets to control for every round. They had several rounds. Whoever wins that round gets to control the lights on the Ferris wheel. What a delight for whoever won. I didn't win in my family, but whoever won got to control the Ferris wheel. Big experience. So that's pretty cool. What other kind of experiences could be like that? I mean, how big is this? You have the phone in your hand, and the web is controlling something out there. It was a great experience, but it still had a couple caveats. I had to join a wireless network, and that was a little tedious. It didn't work the first time, and it also, that interaction with the website was a little sluggish, and that control of the Ferris wheel, as fun as it must have been for whoever was lucky enough to win, that was still probably a somewhat limited experience, right? It wasn't going to be as tight as playing with a remote control car. But we can do better than that. Instead of going through the whole web stack and all the way through the cloud, can't we get the device in our hand to talk to the device just 3 feet away from us in a much more rapid way? I'm sure we could. And what kind of experiences can we build at a theme park? What if at the theme park I could control a train table and we could switch the ways the trains are going, or control the lights, or in a museum, interact with an exhibit, or in the airport, have an interactive kiosk, all sorts of things. So I'm happy to announce that we're working on Web Bluetooth. Web Bluetooth is available today in Chrome Dev Channel on Android and Chrome OS. We are really excited about this. It is going to enable a world of devices to be accessible to the web in a low-friction way. So I want to show you a demo, because demos are cool. So I'm going to show you one of these tea lights. So these tea lights are a little hard to see in a well-lit environment, but I've got it on the projector here. And I can connect to these devices with a simple web page. So I can load up a web page and say connect. And I see the nearby devices. I can select one of the devices I want to control and pair to that device, and the web page comes up. And I can change the colors of the device, and I can do some other things. So this example device has a couple modes that I can put the device into. And I've got responsive control of a device. One device to another, using the web, low friction, no install, and no worries afterwards. That's a great experience. And there's a load of devices just like this. So this is a part of Bluetooth. Web Bluetooth is exposing some of that. And I'm going to explain to you a little bit more, because not everyone is completely familiar with Bluetooth. So I'm going to use a heart rate monitor as an example device to tell you about how Bluetooth works. And in this case, I'm talking specifically about Bluetooth GAT, generic attributes. This was introduced with Bluetooth Low Energy or Bluetooth Smart. It's kind of a schema-based way to think about something. So this device is a heart rate monitor. It's on a strap. You can put it on your chest. You can exercise, and it'll track your heart rate and notify whatever device is listening. From a conceptual point of view, Bluetooth considers the heart rate device as an object. And that device has services. So it has, of course, a heart rate service to give you the data about the heart rate. In the heart rate service, there's multiple values that you can read. They're called characteristics. One is the body sensor location. It's just an enumeration. OK, is it on your finger, your wrist? It's on my chest. OK. The other value is the heart rate measurement. It's a couple of bytes, some flags, the averaged value, and the very specific RR intervals between the peaks of the heart rate. Now, as a device, we're not done. This is a battery-powered device, so there's also a battery service. And the battery service has a battery level characteristic with a simple value 0 to 100 for how much battery is there. I like demos. Let's take a look at this device live, because I'm wearing a heart rate monitor, of course. I mean, who can do a presentation like this without doing that? So I don't know what my heart rate is. When I'm at rest, I'm usually at like 50, 60. I'm a fairly fit guy. Let's see what we can do on video. Maybe soon we have demo gods working for us. My heart rate is increasing. All right, and there we are. I'm at 145. Yeah. Very good. Now, if I was a Buddhist monk and well-skilled, I could bring it back to 50 now. But I'm not. All right. This is a developer conference. Let's talk about code. So from that device, how do we connect from a code point of view? Web Bluetooth introduces navigator.bluetooth. And on that surface, we have request device. When I call request device, I let it know what I'm looking for. In this case, I'm looking for any devices that are advertising a service called battery service. And that's a standard service name. These could also be proprietary. So many, many devices exist with many unique and proprietary custom services. And those are addressed by just a UUID instead of a string name. When you request this, Chrome will show a dialog. It's a picker, kind of like a file input picker. It shows the nearby devices. We select one. And this is how the user grants the permission for both privacy and security to communicate with that device. After you pair, we are going to resolve a promise. It's a promise-based API. As the promise resolves, we then get a device object which has basic information, such as the name and the advertised services of that device. And we can then call device.connectGAT. Once we connect, we can ask for a primary service. You can recognize we're walking down through that hierarchy I explained before. From the service, we can ask for the characteristic. From the characteristic, we can request a value to be read. And when the value is read, we can then get the bytes. We can parse those bytes and use them in any way we need to. Of course, not only do you have read, you can write, but there's also notifications. So the heart rate device generates notifications automatically. If you go to a characteristic and start notifications, that registers an event handler, an event listener. And you can use that event listener to get updates whenever the device sends you a notification. Again, parse the values and use them. It's a pretty easy API to use. It's fast to work with a lot of these devices. But to make it even easier, we've produced a Polymer Platinum element. So the Polymer element allows you to use a simple set of HTML to describe the device and the characteristics you're interested in. You can bind them using templating as well, so that when you read the values, you can automatically have other DOM elements updated using the templating system. It also allows you to automatically push values when you write to the value. So it greatly simplifies the JavaScript necessary and makes app development even easier when you're using Polymer. So let's go up to the big level. What's going on? Well, this is experimental right now. It's still behind a flag, but it's on dev channel. We already have people loving it in the code lab because we have devices out there for you to play with. You can try it out at home too. And what we're looking for is information back about the specification. Do we have it right? Do we need to change this or that? I'm excited to see that Mozilla has also announced development is in progress. So it's good to see that we have multiple vendors implementing also. And to make it easier for you to try it out, we've also developed a low-energy peripheral simulator. Maybe you don't have a gadget right around to toy with. We've made a simple Android app that can act like a battery service or a heart rate device. And if you have an Android phone around that can act in a peripheral mode, many of the newer models do, you can then have that functioning and experiment with it in JavaScript. We have been having a lot of fun playing with different devices. Juggling balls, airships remote controlled. They may or may not be grumpy cats. We've got thermal printers and all sorts of fun and exciting toys. This is one of the best things you can play with from an API, especially because you're connecting outside of your device to other devices around you. We're also working with other ways to connect to other devices. For example, Web NFC and Web USB are being experimented with in the code base as well. There is one problem remaining. That experience I had at the theme park, it would have been easier if I was just using Bluetooth and I didn't have to jump on a wireless network. But would I have needed to type in the URL? Even that would have been some work. And you're saying like, oh, you're pretty lazy, Vince. Well, yeah, I'm a dad. Kids are running around, right? I have no time for that. When I walk into an area, can I just have my phone know about the web pages that I need to connect to those devices? Well, we're working on that too. So I'm happy to invite up to the stage Scott Jenson.
Hello. OK. So what Vince was talking about is that there's a lot of smart devices out there. We all are using them right now. We've seen the smart TVs and the smart vending machines and even bus stops. But today, what happens when you play with them is they all have their own app. And that's for good reason, because there's no really other alternative. But if we believe in Moore's law at all, this can't be stable, right? So maybe in a year, we may have, say, maybe 7 devices. And then shortly after that, we may have like 30 devices. I mean, it just can't scale. Now, this is not an anti-app comment. It's just simply an interaction on demand comment. If I want to walk up to something quickly, I just can't deal with all of that. There has to be kind of a better way of doing that. The superpower of the web is interaction on demand. It's just a tap away. It's just a selection. It's just a click. It's so easy to get to another page. That seems kind of useful for the Internet of Things type project. So how can we tap into that? Because for the last 25 years, all the people in the open web community have been working so hard to create this amazing rendering engine, this ability, this DOM that can do so much. And I think we should be pretty proud. It's pretty awesome. But we've kind of forgotten this place, the address bar. It's kind of boring. It's like, really, the big thing that we've been able to do in the last like 25 years is if I type T, it autocompletes to Twitter. Cool. It's like, really, we've taken the most, to go anywhere on the web, it's like, yeah, we got to like type into it, like www.cn. It's like, what is up? We've taken the most amazing rendering engine on the planet, and we strapped a DOS prompt on top of it. I mean, like, what is up with that? It's like, why can't the URL bar be mobile friendly and be more mobile specific? So what we think we need to have is nothing too complicated. We just want a discovery service. We just want the URL bar to find other URLs for us. That's it. So imagine if you were in a physical location and you have a vending machine and a parking meter and a bus stop, and they're all broadcasting a URL. How could you then walk up and discover them? How would that work? Well, the idea is that URLs are good, and they're a good building block, but you don't want to show just the URL, and you just don't want to list them. You want to be able to have a little bit of sorting and ranking and a little bit of information. So if I find them, it should zoom up a little bit and like give you maybe a favicon and a title and a little snippet so that you can kind of see what each thing is. And then, of course, when you click on it, then, of course, you just go to its web page. We just want to get you to the web as fast as possible. So in a sense, how would this work? Well, we've got a couple of ideas we're playing around with, but the simple one right now, kind of like the new black, is basically Bluetooth Low Energy. Everyone is using that right now. And what's lovely about Bluetooth Low Energy is it has kind of the wireless equivalent of a UDP packet. It just broadcasts this advertising packet over and over and over again. And what's nice about it is that it's completely connection-free. It sends it out, and 10,000 people can receive it. And it can't know. So this beacon can't track you, which is important. Now, if your phone happens to come by, it can actually pick that up and see that URL. And that's all we're trying to do. And so the physical web, this project I've been working on now at Google for about 2 years, is this idea about bridging the web and physical devices. The idea is that you walk up to a device that's broadcasting a URL, and your phone just picks it up and takes you there, just takes you to a web page. So it flips things around a little bit. We're so used to web pages being like a big portal, and you have this one page that millions of people go to. The flip side is you have millions of devices, and each one has its own web page. It's still the web, but now it's a little bit more granular. And the key thing, the superpower of the web is what we're unlocking, the idea that you can walk up and use any device just by a tap. Now, here's the critical thing, though. It's really can't be, there's no interruptions involved, because we're so used to existing beacon technologies giving you notifications. This can't do that. You actually have to respect the user's privacy at this point, and they will only see that list if they ask for it. And they will only go to the web page if they click on it. And that's really important, because if not, you could walk into a mall and your phone would go, it would like vibrate out of your pocket if you have 50 different beacons going on. It would go nuts. So you have to respect the user and only give them that list if they ask. So at its simplest, we just have a device that's broadcasting a URL that takes you to the cloud. But I get 2 questions all the time, and I know they're rattling around your head, so I'll just answer them right now. The first is, Scott, isn't this just QR codes? Well, we all know how well QR codes have worked in the past. And there have been countries where it works quite well, so I'm not trying to say that they're completely useless, but there's limitations to QR codes. They're best kind of like on posters or on receipts. And besides, if I walk into an area with like, say, 15 or 20 beacons, how do I see them all at once? And more importantly, what happens if I have something that's 50 meters away? Do I have to walk over to it to kind of get it? And by the way, anybody has a smart light bulb? QR codes and light bulbs don't work really well. So I think there's nothing wrong with a QR code, and technically, we are doing the same thing. I mean, when I describe the physical web to people, I say, it's kind of like QR codes, but awesome, right? And it kind of undersells it a little bit, but it gets the point across. We're just getting the URL to you as quickly as possible. The other question I get a lot is, aren't you getting a lot of spam? I mean, all these things, all these URLs around. I'm like, well, there's an issue with that, but that's why what we do is we go through a proxy. We grab all the URLs, send them up to the proxy, which gives us a couple of huge advantages. The first is the proxy can cache everything, so it can give you the title and the snippet and all that stuff, handle URL redirection and things like that, and protect the user. So the user does not have to contact the website and be fingerprinted. It protects the user. That's really important. It also saves a lot of data because it's already pre-cached. And the other thing it can do is it can filter and get rid of malicious beacons, which helps quite a bit. Now, if there is a concentration effect going on, that all this is going through one particular proxy, but I'm not sure I've mentioned it, but the physical web is completely open source. So you can have your own client, and you can have your own proxy service. So you don't have to go through ours. We think that's a very important part about being built on the open web. Now, we're also built in the open web based on Eddystone. Eddystone is Google's open source beacon format. And there's 3 formats, the UID, the telemetry packet, and the URL. And we're just based on the URL. We put the URL directly into the advertising packet, and it just broadcasts over and over and over. And that's really important because you don't have to register. You just buy the beacon, you put the URL in, you don't ask anybody's permission, and you just put it up on the wall, and you're working. It's pretty straightforward stuff. So what we're trying to create is these 2 clouds, this cloud of standard devices, or just actually all sorts of devices, but they're all broadcasting in a standard way, just all broadcasting URLs. That's the critical piece. And then all sorts of different clients that could then be looking for and presenting them to you. And that can be variations, that can even be proprietary if you want to, but it allows this kind of variation to exist. So let me give you an example of how this would work, specifically in relation to what Vince just said about web Bluetooth. So here's a Happy Meal toy we built. By the way, all these demos are out there in the common area for you guys to play with later. So here's a Happy Meal toy. So we have a little 3D printed turtle here, and we are now browsing using the physical web, and we see Tuga the turtle. And when you click on it, the physical web is done. We're now on the web, but it loads up the JavaScript Bluetooth, and now you can say, oh, I want the turtle to be happy, or I want him to be silly, or I want him to be grumpy. And of course, then once you set the parameters, the turtle does different things, or change the colors. And once the turtle is configured, you can pick him up, and if you turn him upside down, he gets really grumpy and he vibrates and so forth. We had way too much fun building this. In fact, we had to stop because we were having way too much fun. But the intention is to show that this part could be built for $2, and you can walk up and play with it now. And it's really critical from Vince's point of view that you don't have to go through pickers or anything. You just say, here it is, click on it, and you're in. It's really quick and fast. So this is the first primary use case of the physical web. We'll call the web Bluetooth, where your device broadcasts a URL, you go to the cloud, you get the web page, and then you talk back to it with JavaScript. That's the most innovative, creative thing we can do because it unlocks a whole new type of hardware. But let's not forget the classic web. We'll call this like Web 1.0. You can have a bus stop that broadcasts a URL that takes you to a web page that says, the next bus is in 5 minutes. It's just classic 1.0 web, and I still think that's pretty awesome because it unlocks all sorts of little bits of information, because it means every physical object in the world can have just a virtual note card for you just to have a little bit more information. And also what happens, that I think is important, as you've seen here in our conference, the web is getting better. And as the web gets better, the physical web just kind of looks more awesome, but we're not doing anything different. The web is just making us look better. So in this case, we have a restaurant buzzer. So you walk up, you pull down the thing, and it goes, hey, here's Bob's Deli. You click on Bob's Deli, and it, again, physical web is done. And it shows up, and now it uses a service worker to register for push notifications. You get in line, you push the button, turn the phone off, put it in your pocket. And then 3 minutes later, 4 minutes later, when it's your turn, your phone buzzes in your pocket because you opted in. And then, of course, you can then get in line and get your stuff. So this is exactly the same thing, but now with push notifications becomes a lot more interesting. So, and the third and final category is what we call cloud pass-through. And this is my vending machine or the parking meter out there. And the idea here is that you send a URL to my phone, you then go to the cloud, but then it talks back to the device, not you. And it's kind of lovely, by building this on top of URLs in the web, we kind of let where the functionality occurs float between the phone and the cloud and the device. The user doesn't care. I'm just pointing out to you guys that because we're based on the web, this gives you lots of different places where you want to put the functionality. In this case, it goes through the cloud. So here's the parking meter demo, which again is out there. I pull down the notification manager. I see that there's the parking meter, pay at parking. You click on it. Physical web's done. I pull up a web page, and now every time I tap, I'm sending a WebSocket event. As I click, it goes up, up, and then pay, and I'm done. And anybody that lives in San Francisco is kind of brought to tears when they see this. Because we do have a parking meter app that nobody uses, and it's like, this would be pretty fast if we actually had that. So I'm going to really beat you over the head with this, because every time I give this talk, people go, so what's your SDK and what's your protocol? I'm like, it's just a URL, guys. It's literally just, we discover the URL to the parking meter, and when you click on it, you go to the web, and there's no funny business going on. You're just talking to the web. Now, in this particular case, we had a pretty smart parking meter. It had a connection to the internet. It was talking, and people are saying, Scott, that's so complicated. Am I really going to have like a Raspberry Pi in every device? This is way too complicated. I'm like, you have heard of this thing called the Internet of Things, right? It's like everything is going to kind of connect. Well, here's a device right here. This is a Particle, a company called Particle has got a board for $39. Arduino, GPIO pins, and it takes 10,000 messages per month for like a $2 fee. And you can connect to it, and that's in quantities of one. Imagine in much higher quantities. The whole idea that devices are getting their own connectivity is a huge booming thing right now. And it doesn't seem hard to believe that we're soon going to have devices that have their connectivity, and then we'll have our connectivity, and what we just need to do is rendezvous. How do we actually find each other? And the physical web is kind of like, yeah, I'll meet you at this URL. It's over here. It's really pretty straightforward stuff. Now, clearly in homes, when you can be on the same subnet, you can kind of do more complicated things. But for public spaces, this becomes a lot more interesting. The other thing that this journey I personally went on is like the first thing I built was a big vending machine. Because of course you want to control big stuff. But then you realize that actually little is kind of cool. It's like, wait a second, just how about a bus stop? Or how about a movie poster? it's really kind of revelatory to realize how the small is beautiful kind of thing. And the smaller you go, the more interesting it gets. But even if you get rid of that, start realizing it's not even corporate stuff, it's personal stuff. So if I'm presenting slides, my Chromebook could be broadcasting the URL to my slides to the room. Or my dog collar or cat collar can have something, so if they get lost, someone could find them and call the Humane Society and report the dog. Or even a for sale sign on the back of my car. I mean, there's a lot of really lightweight personal things that aren't even corporate. We think this unlocks a lot of really fun stuff. We all know about the long tail of the web, how the bottom gajillion pages are so much bigger than the top 10 or 20. And that's what the web is always based on. It's the little stuff. So when we talk about vending machines or bus stops or luggage or toasters, whatever, each one of these cases is kind of, honestly, meh, it's okay. But taken together, it opens up this whole new way of interacting with devices, and it kind of forms what I kind of call this long tail of interaction, where all devices can be interacted with. And we think it's a lot more interesting. And by the way, it doesn't have to be IoT either. This can be the world's stupidest toaster. Really? It just is a toaster, and all it wants you to do is recycle it or have a video to change the crumb tray. Because we all had, you buy a toaster and it's covered with QR codes because they so want you to engage. And what do? You throw it away, right? And some marketer loses his wings, And, but the whole idea is that now you can engage with the person after it's been bought, and it's just a toaster. And I think this is really interesting stuff, and we don't have to have it be kind of based on IoT type stuff. Now, we've been around for over a year now, had a GitHub. It's one of Google's most popular GitHubs. It's been kind of fun. And I'm really excited because just a couple weeks ago, Opera announced that in Opera Labs, they support the physical web, and they have their own proxy service, which is really awesome. So other people are doing it. We're talking to other groups as well. So it's beginning to get built out. And it's really critical that this is seen as part of the open web. It can't succeed if it's a Google product. It has to be it can only succeed if we, as a community, want it to succeed. And we're really excited that people are getting behind this. I'm also pleased to announce, because I get this question 3 times a day, is that today at 5 o'clock, Chrome Dev, when it releases, will have early support for the physical web built inside. It's been a really long time, and I'm really excited to kind of say it. Now, it is early. It's a little buggy. Please be patient. It's behind a flag. But I'm really excited to be able to share it with you guys. Now, we actually have been available in iOS for the last 4 months. So if you have an iPhone and you have Chrome, you can use it right now. If you have Chrome, you got to wait 2.5 hours. Sorry. If you really want to go out after our talk and play with the demos, you can download our developer app. Just search for Physical Web in the Play Store. You can download it right now. But it's coming. We really want to talk to you guys about it and play with it, ask questions. We're very active on the GitHub, and so please find us afterwards and talk to us more later. Oh, and by the way, tomorrow morning, not today because it would create a complete mess. Tomorrow morning, you guys can all get your own Eddystone beacon, which you can then program and find and play around with. So we'll be handing those out tomorrow morning to play with. Thank you very much.